Good day, students. Welcome to mathgotserved.com. And this clip, we're going to be going over how to solve log equations that involves two logs and a number. Don't forget, there's a practice problem at the end of this presentation for you to try out. So be sure to watch the entire presentation and try out the practice problem to demonstrate mastery of the contents of this tutorial. Alright, to get us started, let's do a real quick review on the steps for solving log equations. We went over this in the previous presentation before this. So here are the 5 steps. So to solve it, you're going to use steps 1 to 4, the CCES steps, and then step 5 is just to check, okay? So first thing you want to do is you want to collect the log terms to one side with the number on the other side, okay? The type of problem we're going to be dealing with here is a situation where you have two logs and a number. All right, so you collect the logs to one side, a number on the other side. You condense the logs into one term, and then you eliminate the log using exponentiation, and then you solve the resulting equation. Okay, in this particular presentation, you also have to check your work. Do not forget the domain of log functions. The domain of log functions are the set of real numbers that are greater than 0. So what does that mean? It means that the log of 0 or negative numbers is undefined. So if you end up with any term like that, when you are doing your check, any number that has a log of 0 or log of negative number, that term will be undefined. Hence, that particular solution will not be a solution. It will be extraneous. All right, so let's go ahead and take a look at an example. Okay, so for this particular example, instructions are for us to solve and check. Solve and check. Okay, so let's say we have the log equation log base 8 of x plus 30 equals 2 minus log base 8 of x. Okay, so let's solve this. So one thing you want to remember, first of all, you notice we have two logs in this particular setup and a number. All right, this is the type of problem that the steps that we outlined earlier are applicable to. So you want to collect the logs to one side of the equation and put the number on the other side. We already have a number on the right side, so we'll simply move this log term to the left side of the equation, the log base 8 of x. So use the inverse operation. We're going to add log base 8 of x to both sides of the equation. All right. Now, when we do that, on the left side, since the logarithmic arguments are different, they're unlike terms, we'll be left with log base 8 of x plus 30 plus log base 8 of x. All right, and that will be equal to 2. These two add up to 0. Okay, so now what we just did is we just did the collect step. Okay, now we're going to go ahead and condense. Let me put the steps here again so we can keep track. So C, C, E, S, and then we check. Okay, so you collect the log terms, you condense them, you eliminate, all right, and then you solve. And in this particular problem, we're asked to check also, so we'll definitely do the check at the end. All right, so we just did the collect step. Now let's do the condense. Now to condense, we're going to use the quotient and product properties of exponent of logarithms. All right, it's related to that of exponents too. So here we have the sum of logs. So remember that if you have the sum of logs is equivalent to the product of the logarithmic arguments. So remember the formula. If you have log of x plus log of y, it's equal to log of the product of the log arguments, okay? And then if you have log of x minus log of y, guess what that's going to be? It's going to be the quotient, right? These are known as the product and quotient properties of log. So we're going to use the first one, the product property. So you notice the log arguments on the left side, so x plus 30 and x. we're going to be finding the product of those two terms. All right, so we're going to have log base 8 of x times x plus 30 is equal to 2. Now let's simplify the product of x and x plus 30. We're just going to distribute this x to both terms here. And then when you carry out that distribution, you're going to have log base 8 of x squared plus 30x. Okay. All right, so we're done with the condensed step because now we have one log with the logarithmic argument nicely simplified. Now we're going to move on to the elimination by exponentiation, all right? So we're going to use the inverse property of log. Remember, if you have log base b of b to the x, is just simply going to be x. Because if the base of the log and that of the exponent are the same, they cancels out. So to take advantage of that property, we're going to exponentiate both sides using 8 as the basis of our exponentiation. Okay, so we're going to put a big 8 on the left and the right. And then the left side exponentiated will be a little log base 8 of x squared plus 30x. And then on the right side, a little 2. All right, so we selected 8 as a base for our exponent so that it matches the base of the log. On the left side, you see the cancellation action happening there. That's exactly what we want to eliminate the log. Okay, so we're left with x squared plus 30x equals 8 to the second power, which is 64. All right, so what we're going to do next is solve this resulting equation. What do we have on our hands now? We have a quadratic equation. So there are different ways you can solve a quadratic equation. You can use factoring. You can use a quadratic formula, completing the square. Let's try factoring here. All right, so let's put it in standard form first. So we have to set it equal to 0 with descending order of degree terms. Okay, so when we do that, we're going to end up with the quadratic trinomial x squared plus 30x minus 64 equals 0. Okay, so let's factor using the AC method. Make ourselves a nice little X game situation here. AC goes on top, B goes on the bottom. So that's A, B, C. Remember to put it in standard form first before you look for A, B, C, okay? So A is 1, B is 30, and C is negative 64. So AC is negative 64, B is 30. So what two numbers multiply to give you 64 and add to give you 30? Let's exhaust the possibilities. So what pair of numbers multiply to give you 64? We know 1 times 64 gives us 64. 2 times 32 gives us 64. 3 no 4, yes. 4 times 16 gives us 64. And we know that 8 for sure gives us 64 because we just multiplied 8 by itself, right? So 8 times 8 is also 64. All right, so which pair gives us 30 here? The first one gives us 63 or 65. No, this one gives us 30 or 34. This is what we are going to be using right here. 2 and 32. Okay, so let's put it in here. We have 2 and 32. Now the sum has to be, or the difference has to be 30 and the product negative 64. Since the difference is positive, that means the small number is negative. Okay? With this setup that we have here, since a is equal to 1, we can skip the grouping process and just go right to the factored state. So we can just jump right to the factored state, which is x minus 2 times x plus 32 equals 0. Now we're going to use the zero product property to finish this off. You set both factors equal to 0. All right. And then the first one, you add 2 to both sides. You have x equals 2. This one is subtract 32 from both sides. You have x equals 32. Negative 32. So these are our potential solutions. So which one is real and which is extraneous? Well, we're going to have to do our check to determine if they're both solutions, if only one is, or if none of them are actually solutions. So let's go ahead and do our check right now. Okay, so here goes the check part. The original problem is log base 8 of x plus 30 equals 2 minus log base 8 of x. So let's test the first answer, x equals 2. So just plug it into the problem, okay, into the original. So you have log base 8 of 2 plus 30. Is it, we don't know yet, is it equal to 2 minus log base 2, log base 8 of 2? As it simplify this further, this becomes log base 8 of 32. Is it equal to 2 minus log base 8 of 2? So let's add log base 8 of 2 to both sides. So add log base 8 of 2 to both sides. Just condense it so it's easier to determine if they're actually equal, if this is a true statement. Okay, so when you combine that, on the left side we have log base 8 of 32 plus log base 8 of 2. Is it equal to 2? Is it? Now when we use the product property of exponents that we had outlined here, we can multiply the logarithmic argument. So this becomes log base 8 of 32 times 2, which is 64. Is it equal to 2? Now can we write 64 as a power of 8? Absolutely. 64 is 8 to the second power. So right, it says log base 8 of 8 squared. Is it equal to 2? So you see here we have an exponent and a log with identical bases. So we can use the inverse property of logarithms. This cancels out, leaving us with a statement is 2 equal to 2. And the answer is absolutely. So this is good. The first answer is good. Now let's test out the second one. Looks like there might be a problem here because it's negative, but you never know yet. So let's go ahead and just plug it in and see if it works out. Alright, so for the second part of our check, we're going to be using x equals negative 32. So we're going to plug in negative 32. We have log base 8 of negative 32 plus 30. Is it equal to 2 minus log base 8 of negative 32? Okay. Alright, if you notice, there's already a domain violation in the last term. Right here, that's a problem. And even if this one right here, well, let's simplify this so you see. So if we simplify this, we have log base 8 of negative 2. Is it equal to 2 minus log base 8 of negative 32? So this term right here is undefined because you can't take a log of 0 or a negative number. And then this is also undefined, so this is not a solution. So x equals negative 32 is not a solution. So this guy right here is extraneous. So the only solution to this logarithmic equation is x equals 2. Okay? So that's how you solve log equations involving two logs and a number. All right, now it's your turn for a practice problem. So for this particular situation, we'd like you to pause this video presentation and try out this problem. The task is the same as before. We want you to just solve and check. Okay, so for this practice problem, let's say you have log base 2 of 2x is equal to 2 minus log base 2 of x plus 1. Alright, so go ahead and pause this video presentation and try out this problem. When you're done, we're going to show you what the correct answers are. All right, welcome back. So hopefully you had a chance to try the problem. So here goes the solution. Go ahead and check it out. How well did you do? If you got everything right, go ahead and destroy that like button for us. If you got it wrong, you can still hit the like button and let us know what questions you have. Where did you make the mistakes so that we can assist you? All right, so that's that. Thanks so much for taking the time to watch this presentation. Don't forget to support our channel with your likes, comments, and subscriptions. Tons of support resources can be found at mathgotserved.com. Do check it out. We will see you in the next video. Take care.